So our geometric sum for our formula for the sum of an infinite geometric series, sum from I equals whatever to infinity, okay, of an a sub n formula is a first over 1 minus r. A first over 1 minus r is that summation formula. And if the absolute value of r is less than 1, the sum exists. If the absolute value of r is greater than 1, there is no sum on an infinite series. So let's put that into practice and let's look at A. In A, we find our r value first. That value of r is 4. That absolute value is greater than 1. So there is no sum here. Don't try to calculate anything. Don't plug stuff into the formula. It's no sum. Now, let's look at example B. Hang on. Because this r is greater than 1, this is a series that diverges, as in gets further and further apart, which is why there is no sum. On B, that r value is 2/3, which is less than 1. So this series converges, which means it will have a sum. So to find its sum, we need to find a first. A first in this case is a sub 3. And it's a sub 3 because of that 3 on the bottom. So what we need to do is plug the 3 in place of the I. So 12 times 2/3 to the power of 3. 12 times 2/3 to the power of 3. So 12 times, just 1 times, a fraction, 2/3, and I actually probably want that fraction in parentheses, 2/3, and we're going to raise that to the power of 3. There's our answer, okay? Fraction form is preferable here. In your calculator, if you used alpha y equals fraction mode, your answer will be in fraction form already. If you did not use alpha y equals fraction mode, to get your calculator to give you the fraction, hit math, and the first option there says frac. Hit math frac, enter, and I think one more enter, and it will convert your decimal to a fraction. Desmos, if you see just to the left of the box, you see this little thing that looks like a fraction. If you'll click it, it's highlighted gray, dark gray now. It's undone now. If you highlight that, you will get your fraction. So a first here is 32/9. And now we can work on finding the sum. Okay, the sum here, that infinite sum, would be a first, 32/9, divided by 1 minus r, which is 1 minus 2/3. A first divided by 1 minus r. So I'm going to do a big fraction with some other fractions on it. So a first, I'm going to do 32/9 on top, divided by 1 minus 2/3 on bottom. If you're in fraction mode, the parentheses on the bottom here are optional. If you are using the slash division symbol in your calculator for divide, you absolutely have to have these parentheses. Okay, again, I'm going to touch the little fraction thingy over here, and we get 32/3. So 32/3 is this infinite sum. (32/3), final answer. So let's take a look at C. First thing we need to do is find that R, decide if this can have a sum or not. This R is 3/2. Now, don't get fooled. 3/2, yes, is a fraction, but 3/2 is 1.5. That's greater than 1. So this series diverges, which means there is no sum. There is no infinite sum. We can always find the sum of a few terms, but infinite sums only work when the series converges, as in when R is less than 1. So let's take a look at D. Find that R, the value being raised to a power. R here is -1/6. Absolute value of that -1/6 is 1/6, which is less than 1. So this will converge. So it will have an infinite sum. We just need to find it. First thing we need to find is A first. A first here is A sub 3. Again, this number on the bottom tells you which term represents the first term. Plug in that 3 in place of I. So 18 times -1/6 to the 3 minus 2. Okay, 3 minus 2 is 1. So that's just 18 times -1/6. That's -3. We can put it in the calculator if we want to. 18 times -1/6 to the power of 1 is going to give us, that same thing because it doesn't do anything. That's -3. So A first is -3. Okay. And now to find that sum, we take A first, that -3, divided by 1 minus R, -1/6. Yes, that minus negative becomes a plus positive. Okay, you can put it in the calculator either way, but -3 over 1 plus 1/6. So -3 over 1 plus 1/6. Again, convert that to fraction. There it goes. Convert that to fraction, and that is -18/7. -18/7. So the sum of an infinite number of terms of that series is -18/7. Let's take a look at another one. Let's take a look at E. E is the sum of the series from I equals 5 to infinity of 2i plus 1. First thing we need to do on a geometric series, infinite, is to find the R. R is the number being raised to the variable power. There's no power in here. There's not a power. There's not a value being raised to a power over and over again here. This is not geometric. So yeah, this is a little trick question here. This is not geometric, so there is no infinite sum here because it is not geometric. Only geometric series can have a sum of an infinite number of terms. E is actually an arithmetic sequence because it is a linear equation, 2i plus 1. It's a linear equation. It would be an arithmetic sequence. It could have the sum of a specific number of terms, but not an infinite number of terms. All right, give yourself a minute to try these two problems, A and B, here on the bottom. Go ahead and pause this video while you try those, and then come back and watch the rest of it. So let's look at A. We need to find that R. We've got a lot of fractions in this problem, and it's okay. We need to find that R. Okay, that r is the number being raised to the power of a variable. It's negative 2/3. That absolute value is 2/3, which is less than 1. So this will converge, meaning it does have a sum. So to find its sum, we need a first. A first here is a sub 3. Again, watching that number on the bottom. So plug in 3 in place of I and work this out. 28/7 times negative 2/3 to the power of 3. I'm putting all that in the calculator. So 27/8 times a negative 2/3. Don't need those. Negative 2/3 to the power of 3. That worked out nice and clean. Probably worked out better than you thought it would. But remember, this denominator 3 to the power of 3 is 27. So negative 1 is our a first. And now to find the sum of those terms would be a first, negative 1, over 1 minus r. R is negative 2/3. So you can put that in as negative 1 over, that look like a negative, negative 1 over 1 plus 2/3, because that minus negative does turn into a plus positive. So negative 1 over 1 plus 2/3. So negative 1 over 1 plus 2/3. Again, if you're in fraction mode on your calculator, you don't need those bottom parentheses. If you're just using the division symbol, you will need the parentheses. So this sum is negative 3/5. Negative 3/5. And looking at B, first thing we want to do is identify the R to see if it is geometric even. That R is 3/4, which is less than 1. So this will converge and have an actual sum. We need a first. A first is a sub 0. This number right here. It's fine. So that would be 2 times 3/4 to the 0 power. Well, anything to the 0 power is 1. So this is just 2. Then that sum would be a first, which is 2, over 1 minus r. This would be 1 minus 3/4. So 2 divided by 1 minus 3/4. 2 divided by 1 minus 3/4 is 8. So this infinite sum is 8. So on infinite geometric series, for the series to have a sum, it has to be geometric and it has to have an r with an absolute value of less than 1. The absolute value of r is greater than 1, the series diverges and there is no sum. That's it for 5-3.